Which of the following statements is correct with regard to the angle of deviation D of the monochromatic ray of light produced by a glass prism? Answer 1. D is independent of the angle of incidence. Now we know that it is depending on angle of incidence. Then incident angle is increasing. Deviation angle is changing like this. First it is decreasing and then increasing. Therefore, angle of deviation is depending on angle of incident angle. Then one is incorrect. Part 2, D always increases the angle of incidence. No, it is decreasing for some angles and then increasing. It also incorrect. Third one, D always decreases the angle of incidence. It also incorrect. Then fourth one, D has a minimum value and it is depending on the angle of prism. Yes, D has a minimum value, but it is dependent on the angle of the prism, not independent. Then answer is 5 for the question number. Minimum angle of deviation, D. We can write N equals sin A plus B over 2 divided by sin A over 2. This is the refractive index of prism. Capital A is prism angle. Then D is depending on prism angle and refractive index of prism. Which of the following is a possible path of a ray of light through a glass prism placed in air? We can consider a ray like this. Refractive index of prism medium is greater than refractive index of outer medium. Therefore, this light ray should move like this. It is deviating towards the perpendicular line because of this is the denser medium, this one is the rare medium. For this case, we can consider this angle is greater than critical angle. Therefore, we can observe total internal reflection for this phase. And after that, this medium is rare medium, this medium is denser medium. Then it should move from the perpendicular line. Then answer should be 5. For the question, you can consider other given answers. There are some wrong ways in all 4 answers given in 1, 2, 3 and 4. Consider the following statements made about light passing through a prism. A. Frequency of light changes when passing through a prism. We know that frequency of a wave is depending only on source. It is not depending corresponding medium. Therefore, it is false. Frequency is not changing with medium or if it is passing through a prism. Then B. Light of different colors travel at different speeds inside the prism. Yes. Refractive index of prism medium is depending on color. Normally we are considering refractive index for yellow color as an average value, but refractive index is depending on color. Therefore, light of different colors travel at different speeds. It is correct. Part C. Blue light deviates more than red light when passing through a prism. Yes, it is also correct. We know that when considering colors of white light, we can observe minimum deviation for the red color and maximum deviation for the indigo. Then, sorry, violet. Then we can get blue light deviates more than red light when passing through a prism. B and C are true. Then answer is 4. A monochromatic ray of light incident upon a prism of refracting angle A and emerge as shown in the diagram. Consider the following statements made about the angle of deviation D. Statement A, as the angle I is increased from 0, the value of D passing through a minimum. Yes, it is correct. We can consider this graph. Then B, D is 0 when the ray enters the prism normally. No, it is false. Normally means the ray should be perpendicular to the first surface of the prism. But we can observe a deviation from this surface. Therefore, there is a deviation. The deviation is not 0. Then B is false. C, for a given value of I, D does not depend on A. So we have not studied a point like that. Always minimum deviation, capital D means minimum deviation. Minimum deviation is depending on prism angle and refractive index. Therefore, C is incorrect. Then only A is correct. Answer is 1. A ray of light incident on a glass prism is shown in the figure. Statement A, irrespective of the value of angle A, the incident ray always emerges from opposite phase. Now it is false. Angle of emergent ray is depending on prism angle. Therefore, A is incorrect. B, for a certain value of angle of incident, the deviation of the emergent ray is minimum. Yes, it is correct. There is a minimum deviation. Then statement C, there is an angle of incidence of the ray 4, which the angle of emergence equal to the angle of incidence. There is an angle of incidence for the ray for which the angle of emergence equal to the angle of incidence. Yes, we know that for the minimum deviation, the angle of incident is equal to the angle of emergence. This angle equals this one for the minimum deviation. You know that for the ray corresponding to the minimum deviation, ray is passing prism symmetrical. Then C is correct. B and C correct. Then answer 3. A parallel beam of light is incident on a prism as shown in the figure. The angle theta between two reflected beams is equal. We can consider given diagram. These two rays are parallel. Then reflected rays are this ray and this ray. We know that the angle between reflected rays, this angle, I will consider it as theta. It should be 2 times of this angle. Theta equals A over 2. Sorry, theta equals 2A. 2 times of prism angle. We can prove it geometrically, but we have to remember that when considering parallel rays and reflected rays, angle between reflected rays should be 2 times of prism angle. Then answer is 4. A light ray deviates from a prism with the minimum deviation of 30 degrees. If the angle of prism is 60, the refractive index of the material of the prism is. We can use the equation for the minimum deviation. I will consider n equals sin A plus d over 2 divided by sin A over 2. Then we can substitute values. We have to find the refractive index n. Sin A is the prism angle. Prism angle is given as 60 degrees. And minimum deviation angle is given as 30 degrees. 60 plus 30 divided by 2 divided by sin 60 divided by 2. 60 plus 30, 90. 90 divided by 2, 45. Then sin 45 divided by sin 60 divided by 30 means, 60 divided by 2 means 30, sin 30. Now we can substitute values. Sin 45 is 1 over root 2 divided by sin 30 is half. We can multiply by the reciprocal. 1 over root 2 multiplied by 2. Then we can cancel out by root 2. Then answer is root 2. Fourth one is the correct answer. When white light passes through a prism, glass prism, which of the following colors deviates least? We can consider colors of white light: red, orange, yellow, green, blue, indigo and violet. We can observe minimum deviation for this side. Red color has a minimum deviation, but they have not given red. Therefore, we have to consider orange has a minimum deviation. Then answer is 2. The setup shown in the diagram is used to focus the parallel beam of light to the point X. The respective optical elements A, B and C should be. There are 2 rays like this. We can place a prism at this place with 90 degrees prism angle. Then we can observe this angle is 45 degrees. It means it is greater than critical angle of glass relative to air. We know that critical angle of glass is approximately 42 degrees, but this one is 45 degrees. Therefore, we can observe total internal reflection and same thing for this place. The ray will like this. Path of ray is like this. For the second ray, we can do same thing. Then element A should be a prism 45 degrees and 90 degrees angle. Prism with 45, 90 angle. Then we can do same thing for the object B. We can place a prism like this. Then path of A will be like this. And finally, we can place a convex lens to focus this right face. Then A should be 45, 90, 45 prism. B should be 45, 90, 45 prism. And C should be a convex angle. Then answer should be 5. A prism is placed on the prism table of a properly adjusted spectrometer, and the refracted image of illuminated collimator sheet is observed while rotating the prism table, starting from a large incidence towards a small angle. As the prism table rotates, we have to consider the deviation. It is the experimental procedure to find the minimum angle of minimum deviation. When rotating prism table like this in this direction, when rotating prism table in this direction, we have to move telescope in same direction to observe it again. And again we can rotate in same direction, we can move telescope in same direction. But after rotating the angle, then we have to move the telescope in opposite direction. We can consider it is the minimum deviation angle. It is the way corresponding to the minimum deviation angle. I will explain it like this. If this one is the first condition, we have to decrease the incident angle. It means we have to rotate prism in this direction. When decreasing this angle, we can observe the minimum deviation angle, and after that, when rotating prism in this direction, we have to move the telescope in opposite direction. Then we can consider given answers. Answer 4 is the correct answer. The image will first move in the direction with decreasing angle of deviation, turn back and move in the direction with increasing angle of deviation. Then fourth one is the correct answer.